In the last video, we converted from base 10 to another number system, and in this video, we are going to convert to base 10 from another number system. And the steps go like this. Step 1, write your number above the correct powers of your base. Step 2, multiply the digits by the place value for each position. Step 3, add them up. And once again, you'll see these steps in action and it'll make a lot more sense. So our first question is, convert the following from their bases to base 10. So we have the number 4726 or 4726 in base 8. So let's set it up first. We have 8 to the 0 here, or a 1, which is going to have the 6 in its place. 8 to the first, 8 squared, 8, don't know what I'm writing. 8 to the third. And 8 to the third is 512, 8 squared is 64, 8 to the first is just an 8, and we have 4726. We just write our number above its corresponding base. And now, oh, that's not right, not 52, 512. And now we just multiply our base by the corresponding number it goes to. For example, we'll start here, 512 times 4, which is going to be 2048, plus 64 times 7, which is going to be 448, plus 8 times 2, which is 16, plus 1 times 6, which is just a 6. And then we add them up to see what we have in base 10. 8 plus 8 is 16, plus 6 ends in a 2, which is 2 here, plus 6 is an 8. 4, 5, 6, 7, we have a 1 here and a 1 here, which gives us a 5 here and a 2 here. So the number 4726 base 8 is 2518 base 10. Now we'll do the same thing with the next problem just for practice. If you think you have it, take a minute, pause the video, and see if you can do the conversion on your own. So we have 1, 2, 3, 4, 5, 6 places. 1, 2, 3, 4, 5, 6 places. We have 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, and 2 to the fifth, which is 32. That looks like 25. That's 2 to the fifth. 32, 16, 8, 4, 2, 1. And we have a 1 here. 0, 0, 1, 0, 1. And in order to figure out what my number is in base 10, I do my 32 times 1, which is 32, plus 16 times 0 is 0. 8 times 0 is 0, so we don't have to worry about those. But I have a 4 times 1, so I'm adding 4, and then I'm going to add a 1. This one doesn't matter either, which gives me 37. So this long number base 2, you might notice that a longer number in base 2 is a shorter number in base 10, and vice versa from the previous problems that we did. But we end up with 37 in base 10. Now while we're here, it's worth mentioning, computers have gotten much stronger. More storage means less digits, which means more digit symbols. We've moved from a world which needed simplicity to a world that needs more storage. We all are always worried about how much storage we have left. So, because of that, we have moved into what's called a hexadecimal system. Hexadecimal system is often used with computers, maybe even systems a little stronger than this. But a hexadecimal system is a base 16-digit system where we only have 10 digits, so we had to make a few up. We changed to letters, where A is a 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So for example, let's see what something simple like EC7 would be in hexadecimal or base 16. So we have 3 digits. This is going to be 16 to the 0, 16 to the 1, and 16 squared. And we have 16 to the 0 is just a 1. This is a 16, and 16 squared is 256. Now we have an E. E, C7. Remember, an E was a 14, a C was a 12. And we follow the same rules. In order to convert to base 10, I'll switch my color, we just have to multiply this by that. Add it to this times that. Add it to this times that. So first we have 256 times 14, which is 3584. Adding it to 16 times 12, which is 192. Then we're going to add 7 to that. And we see that we end up with a pretty big number. What's this going to be? 3584, 192, 7, 3,783. So when you go above a base 10 system, when you go even higher from a base 10 system, you end up with less digits, thus needing less storage to store it all in. And that is your number systems. That's your basic number system.